Hello everyone, in this video we'll learn a C++ program to create a linked list of n nodes and insert a node in the beginning of a linked list. As we know, linked list is a linear data structure. In linked list, every node is divided into two parts. First part hold the information and second part hold the address. The first node of the linked list is called a head, while the last node of linked list is called a tail. As we see, the last node of a linked list will have its next pointer as a null, since it will not have any memory address pointed to. Since each node has a pointer to the next node, data item in the linked list needs not be stored at continuous location. The nodes can be scattered in the memory. We can access the nodes anytime as each node will have an address of the next node. We can easily add data item to the linked list as well as delete items from the list easily. It is possible to grow or shrink the linked list dynamically. There is no upper limit on how many data items can be there in the linked list. So as long as memory is available, we can have as many data items added to the linked list. Given linked list having three nodes 20, 30 and 40, if we want to add a new node 10 as the first node of the list, then the head pointing to node 20 will now points to node 10, and the next pointer of node 10 will have a memory address of node 20. And after insertion, the linked list become 10, 20, 30 and 40. Let's see the code how to insert a node in the linked list. Then how to create a linked list. The first step of creating linked list of n nodes starts from defining node structure. Every node having two parts. The first part is known as data part and the second part is known as address part. We need a custom type to store our data and location of next linked node. This is our node structure. Struct node. Struct is a keyword. Node is the name of the structure. Structure having two members, data and next. Where data is the data you want to store in the list, and star next is a pointer to the same structure type. Node is the structure, name, and struct is a keyword. The star next will store location of next node if exist, otherwise null. The node structure may vary based on our requirement. You can also have user defined types as node data section. Then declare a pointer to node type variable to store link of first node of the linked list. You can also declare variable of node type along with node structure definition. There are two ways to define the structure variable: inside structure definition and outside structure definition. Now in this case, structure variable defined inside the structure definition. After that, declare two functions. First function is for create a linked list and second function is for traverse a linked list. Void is a return type, create list is the name of the function and function having one argument, that is n. N denotes total number of nodes in a linked list. In second function, void is a return type and traverse list is the name of the function. Then inside the main function, declare a variable n. N is for total number of nodes in a linked list. Then input number of nodes to create from user, store it in a variable that is n. After that, call a create list function. When this function call, control transfer to the definition of create list function. With the help of create list function, we can create a list of n nodes. Void is a return type, create list is the name of the function, and int n. N is the parameter. Inside the function definition, declare two more helper variables of node type. That is struct node star new node comma star temp. Star new node and star temp are two helper variables of node type. If the value of n is greater than 0, then create our first node, that is head node. Use dynamic memory allocation to allocate memory for a node, that is head is equal to struct node star malloc function, then size of struct node. With the help of malloc function, we can dynamically allocate memory. If there is no memory to allocate for a head node, if head is equal to null, then print some error message and terminate the program. Otherwise, move to the next step. Then input data from user and assign to head using head arrow operator. Data is equal to data. At first, head node points to null, that is head arrow operator. Next is equal to null. Now we are done with head node. Then we should move to creation of other nodes. Copy reference of head to some other temporary variable, that is temp. Temp is equal to head. Now we will use temp to store reference of previous node. Then create n-1 nodes and add to the list. Apply a for loop for I is equal to 2, I is less than equal to n. And I++, inside the definition of for loop, allocate memory and assign memory reference to a new node. With the help of malloc function. If memory got allocated successfully, then read data from the user and assign to data section of new node. That is new node arrow operator. Data is equal to data. And make sure that new node points to null. Now link previous node with newly created node, that is temp. arrow operator next is equal to new node. Then make current node as previous node using temp is equal to temp arrow operator next. Then I++. Again repeat all the steps, and after that call the traverse list function. When this function call, control transfer to the definition of traverse list function. Inside the definition of traverse list function, create a temporary variable for traversing and return if list is empty. If head is equal to null, then cout list is empty. Otherwise, assign reference of head node to a temp variable. Temp is equal to head. Then repeat below steps till temp not equal to null. And inside the definition of while loop, temp arrow operator data contain the current node data. You can print it or can perform some calculation on it. Once done, move to the next node using temp is equal to temp arrow operator next. Then again go to step 97. Again check the while condition. Temp is not equal to null. Then temp arrow operator data contain the current node data. Once done, move to the next node using temp is equal to temp arrow operator next. After that, declare a function to insert a node at the beginning of a linked list. Void is a return type. Insert node at beginning is the name of the function. Int data. Data is an argument. Then inside the main function, call the function insert node at the beginning. When this function call, control transfer to the definition of the function. Void is a return type. Insert node at beginning is the name of the function and data is an argument. Inside the body of a function, first of all create a new node. Then after that, allocate memory to a new node with the help of malloc function. If new node is equal to null, if this condition is true, then unable to allocate memory. This message is to be printed onto the screen. Otherwise, assign data to the new node. New node arrow operator data is equal to data. Then make next of new node as next of the previous node. New node arrow operator next is equal to head. And then finally, move the next of previous node as a new node. Make new node as a first node. Then with the help of cout, display the message data inserted successfully. Then again call the traverse list function. Run this code. Now after the execution of this code, first of all enter total number of nodes in a linked list. Total number of nodes in linked list are 3. Enter the data of node 1. Node 1 is 20, node 2 is 30, and node 3 is 40. And data in the linked list is 20, 30, and 40. Then enter the data to insert at the beginning of a linked list. So data inserted successfully. After insertion, a node at the beginning of the linked list become 10, 20, 30, and 40. This is all about the insertion of a node at the beginning of a linked list.